So now let's go ahead and check out the derivative of the hyperbolic tangent and see that that derivative is equal to the hyperbolic secant squared of x. So remember, the hyperbolic tangent is the hyperbolic sine divided by the hyperbolic cosine, which if we were to write this out in terms of the exponential definitions, we would get e to the x minus e to the negative x all divided by e to the x plus e to the negative x. So we'll need the quotient rule. Now we can apply the quotient rule to this expression over here or to this expression right here. And it's going to be a lot easier to apply the quotient rule to sinh x over cos x. It'll work if we apply it to this, but it'll be a lot messier, a little more complicated, because we're going to have negative signs and chain rules flying around all over the place, and we'd like to avoid that if we could. So we're going to use quotient rule for sinh x over cos x without resorting to exponentials. So the derivative of tangent of x, or hyperbolic tangent of x, is the derivative of sinh of x over cos of x. So this is a quotient, so the quotient rule says the derivative is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So remember, the derivative of sinh of x is cos of x. The derivative of cos of x is sinh of x. So we end up with cos of x times cos of x minus sinh of x times sinh of x, which is cos squared of x minus sinh squared of x. And there's a special identity for hyperbolic trig functions, which says that cos squared of x minus sinh squared of x is actually equal to 1. So what we end up with is 1 over cos squared of x. And by definition of hyperbolic secant, that is the hyperbolic secant squared of x. So that shows us that the hyperbolic tangent of x, if we take the derivative of that, we get hyperbolic secant squared of x.